The rate of flow of water through a horizontal pipe is 0.25 meter cube per second. The diameter of the pipe is suddenly enlarged from 100 mm to 150 mm. So there is a sudden expansion of the pipe. Okay, na? Sudden expansion of the pipe. So 100 mm to 150 mm. The pressure intensity in the small pipe is 15.2 Newton per centimeter square. Determine the loss of head and power loss due to enlargement. So anyhow, given rate of flow of water through a horizontal pipe. There is a horizontal pipe. So first of all, let's draw the diagram. So there is a horizontal pipe and it is suddenly enlarged. Okay, now this pipe suddenly enlarged from diameter from 100 mm to, so from 100 mm to 150 mm, diameter of 100 mm to 150 mm diameter. So it's only enlarged from diameter of 150 mm to 100 mm to 150 mm. There is a sudden expansion of the pipe. Okay, now this pipe is suddenly enlarged. So here initial diameter D1 100 mm, final diameter D2. Okay, now at the same time we given a rate of flow. Rate of flow of water. Rate of flow of water. Rate of flow means discharge. What is another name of rate of flow? Discharge. Here is given discharge. So discharge Q is equal to 0.25 meter cube per second. 0.225 or 1 by 4 meter cube per second. 1 by 4 meter cube per second. So smaller diameter or initial diameter. It's better to write initial diameter or smaller. You can take smaller. No issue. Smaller diameter and the larger diameter. Smaller diameter and larger diameter. Smaller diameter D1 is equal to anything you can take, no problem. But smaller and larger is easy to pronounce it. Smaller diameter D1 is equal to 100 mm and the larger diameter is given 150 mm. Is there any other information? So next given pressure intensity is given 15.2 Newton per centimeter square. Okay, we will see. Next, determine the loss of head and power loss due to enlargement. So first of all, we need to find loss of head when water flows from smaller diameter pipe to larger diameter pipe. So it means due to sudden enlargement there is a loss of head. Okay, na? So sudden గా pipe enlarge అయింది అనుకోండి ఏమవుతుంది మనకి లాస్ ఆఫ్ హెడ్ అనేది ఉంటుంది ఆ లాస్ ఆఫ్ హెడ్ అడుగుతున్నారు సో we know that loss of head due to sudden enlargement is given by loss of head due to sudden enlargement. Sudden గా enlarge అవడం వల్ల మనకి ఒక లాస్ అనేది ఉంటుంది హెడ్ లాస్. సో అది దేని వల్ల enlargement HE denoted by HE. H means loss of head due to sudden enlargement. Okay, HE. Formula V1 minus V2 whole square by 2Z. This is the formula for loss of head due to sudden enlargement. This is one of the major loss in the pipe. So what is V1 and V2? Here V1 means velocity of flow in smaller pipe. Okay, and what about V2? V2 means velocity of flow in, this is smaller pipe V1, and velocity of flow in larger pipe. Okay, na? So V1 means velocity of flow in smaller pipe. V2 means velocity of flow in larger pipe. We need V1 and V2. How do we get V1 and V2? So we have one more important equation, continuity equation. Here in smaller pipe and larger pipe, discharge is constant. Here discharge Q is constant. According to continuity equation, discharge Q is equal to A1 V1 is equal to A2 V2. a1 v1 is equal to a2 v2. Using this continuity equation, we can find v1 and v2. Okay, now here a1 a2 means, here a1 means cross sectional area of smaller pipe, a2 means cross sectional area of larger pipe. Okay, so let's see. So according to from continuity equation, Q is equal to a1 v1 is equal to a2 v2. Okay, so Q is equal to a1 v1, then v1 is equal to what? Transpose a1, you will get q by a1. Similarly, Q is equal to a2 v2, then v2 is equal to what? Q by a2. So here discharge is constant. A1 means cross sectional area of a smaller pipe. So cross sectional area of circular pipe is, so name itself tells us it's a circular cross section. A pipe has circular cross section. So for circle, what is the area? Area of circle is pi by 4 into d square. So area of smaller pipe is pi by 4 into d1 square. What about area of larger pipe? Pi by 4 into d2 square. Okay. So v1 is equal to q by what is a1? Pi by 4 into d1 square. It can be written as pi by 4 means 4 by 5. Pi by 4 reciprocal 4 by 5. So 4q by pi d1 square. So v1 is equal to 4 into discharge how much? 1 by 4 or 0.25. 4 get cancelled. Pi into d1. So here d1 how much is given? 100 mm. So 100 mm is given. So let us convert mm into meters. We know that 1 mm is equal to 10 to the power of minus 3 meters. Now 100 mm is equal to what? 100 mm is equal to 100 into 10 to the power of minus 3 meters. So if you simplify this, you will get 0.1 meters. 100 mm is equal to 0.1 meters. And what about 150 mm? 150 mm means 150 into 10 to the power of minus 3 meters. 150 into 10 to the power of minus 3, how much? 0.15 meters. d2 is equal to 0.15 meters. So this is d1 and this is d2. So first of all, let us convert mm into meters. So here you will get 100 mm means 0.1 meters. So pi into d1 square means 0.1 whole square. So anyhow you will get 1 by pi into 0.1 whole square. So if you simplify this, if you calculate this value, you will get v1 as 31 point, here I got 31.83 meter per second. Okay, na? So this is v1 value. And what about v2? So v2 allows, so v2 is equal to q by a2. v2 is equal to q by, what is a2? Pi by 4 into d2 square. So pi by 4 into d2 square. So reciprocal of pi by 4, 4 by 5. 4 into q, 4q by pi d2 square. v2 is equal to 4 into, again discharge and keep 1 by 4. Discharge value is 1 by 4 meter cube per second or 0.25. Pi into d2 how much? d2 0.25. So 0.15 whole square. 4 get cancelled. You will get 1 by pi into 0.15 whole square. If you calculate this value, you will get 14.15. 14.15 meter per second. 14.15 meter per second. Now we have V1 and V2. Now find head loss due to sudden expansion or sudden enlargement. Formula V1 minus V2 whole square by 2Z. Okay, let us calculate. Now head loss due to enlargement equal to V1 minus V2 whole square by 2Z. So V1 value how much? V1 31.83 whole square minus V2 14.15 whole square by 2Z, 2 into 9.81. HE is equal to, V1 minus V2 whole square. Here I have written separate ways, V1 minus V2 whole square. V1 minus V2 whole square. V1 minus V2 whole square. Okay. Now, so here V1 minus V2 whole square. If you calculate this value 31.83 minus 14.15, you will get 17.68. 17.68 whole square by, and as well here you will get 2.9.81, you will get 19.62, 19.62, and head loss due to sudden expansion. So if you calculate this value, you will get the final answer 15.93 meters. This is head loss due to sudden enlargement. And what about second question? He asked to find power loss. Okay. So power loss P is equal to formula rho G Q HE by 1000. Rho G Q HE by 1000. Okay, na? So this is power loss due to sudden enlargement. So rho value, density of water 1000, density of water 1000 into acceleration due to gravity 9.81 into Q, discharge 0.25, and HE, head loss due to sudden enlargement 15.93 divided by 1000. So 1000 get cancelled, and power loss P is equal to 9.81 into 0.25 into 15.93. If you simplify this, if you calculate this, you will get 30 point approximate value 07 watts. Okay, na? This is the power loss due to sudden enlargement. Okay, so this is head loss due to sudden enlargement, and this is power loss due to sudden enlargement.